All right, this is take 3, and so if this video doesn't happen this time, it's not happening today. This is designed to introduce you to the t-distribution, the real-world distribution for the x-bar mu world of measurements and normally distributed data sets. Okay, first item of business is tonight our homework is chapter 10, number 4. Two different panic problems, one with the list CSB and one with the list Amber. For an A skip, you get to pick one of those that you may skip. If you weren't here in class today, my suggestion is you really should be doing both of them. Today in class, I sent the classroom two groups, CINT and INT data, and data contains a bunch of data lists which you can enter yourself tonight, and CINT contains two programs, T-area and DrawT. T-area is the program that you need to do some of the work tonight, although you should be able to complete your homework, and I will explain how to do that in the next video. You can check online for the classroom slides to check the answers to last night's homework. So what we're doing today is confidence interval, which is the estimate plus or minus the margin of error, and we're doing it for the x-bar mu world. However, the case is in the real world, we don't know the standard deviation of the population. So what do? Well, the best we have is the standard deviation of the sample. What are the consequences? We have more room for error. So instead of the Z curve, which looks like a normal curve, we have the T curve, which is very similar in shape. It just has longer tails because we have more air, so we have more room for error in our curve. This is a very important slide. It goes through the details of panic. We now have mu. We're describing the true mean of the population. The assumptions. The first assumption is the same. We have to have a simple random sample. The second assumption, to check for normality. It could be stated in the problem. Otherwise, if you have a sample size of 15, then you have to make sure we have no outliers and no skew, that your sample, when you do stat plot, looks like a fairly normal population. Definitely no skew. If your sample size is 15, again, no outliers and no strong skew. We can have a bit of fluctuation. And if our sample size is large, as it says in the CLT, all we have to watch out for is no outliers, because now we have a lot of tail area and the outliers can definitely change the scope of things. For the third assumption, again, we just need to make sure that our sample size times 10 is less than the total population, and if that's the case, then we can use this as S sub x over the square root of n as the standard deviation of the sampling distribution. Our test will now be named the T confidence interval for a population mean with blank degrees of freedom, and to get that, we take the sample size minus 1. For the math, we have changed a T star, or the Z star, to a T star, and the S sub x is in place of sigma, baby sigma, and our sentence is still the same. So the last thing I'd like to do on this video is explain how to find a T star. If, let's say, we want to find a T star for an 86% confidence interval, what we would be doing is putting 86% on the inside. 1 minus 0.86 leaves us with 14% divided into two tails. We get 0.07 in each of the tails, and the program T area that I'm going to use asks for the tail area. So in this case, it would be 0.07. All right, bringing up my calculator and choosing the program T area. The first thing it says is, what is the probability to the tail side of the cutoff? The probability is 0.07. What are my degrees of freedom? Well, we'd have to say if our sample size was 10, then the degrees of freedom would be 10 minus 1 or 9. I'm just doing it for instance. And our mean of a standard t-curve is 0 and a standard deviation of 1. And so that would tell me that my t-star is 0.162 if I round properly. So that would be my t-star up here. If I had n equals 10, my t-star would be 1.62. In the next video, I will discuss how to do a total panic problem so you can do yours at home.